It takes a satellite about this size to capture high-resolution imagery from space. Imagine the energy needed to blast it out of the Earth's atmosphere to capture this data.
Right, and that's why you're not in space, right?
That's why we're not in space. It's expensive, it requires a lot of energy, big rockets. That's why we're doing something else. We are utilizing the stratosphere.
So Rima, how is the imagery you capture different from what, say, a satellite will capture?
Well, for starters, we provide 3 times better resolution than the best satellite that exists. Our imagery is also more frequently updated. So, for example, in the Biden infrastructure plan, it is estimated that there are 20,000 miles of road that need repairs in the country. So you can actually imagine that there's a need for a scalable way to monitor those repairs.
So where to from here?
So our goal is to capture daily imagery of all urbanized areas in the country. Imagine something like Google Maps, but live, where you actually can see change happen in the cities that we live in.
So Ignazi, is this the device itself here?
Almost. This is a half-scale mock-up. I cannot show you the real thing. It's our secret sauce, but we can study this mock-up. This is one of our anchor points that we use to hold the balloon to. And it's kind of, you get the size of the real thing with that.
So it's big enough to fit into this?
Exactly.
I see.
Yeah, so we attach the balloon here on the top, and all the guidance and electronics goes in the box. We're going to have the camera here.
I see.
Pointing at the Earth as the balloon flies. And it lands on these legs. So we now use this type of hinges, which are like flexible 3D printed material to absorb all these landing stresses. Typically in aerospace we go big. You all see the large rockets and large vehicles and satellites all around. So a lot of hours were put into making this nimble, agile, and actually very lightweight platform.